Testing categorical probability, one-way table. In this chapter 13, we are going to study qualitative variable. We have a population. In this population, we are going to study one characteristic. We are going to collect this information from the population. Normally, we are going to select a sample, and in this sample, we are going to obtain my data, but my data consists in qualitative data, categorical data, no numbers. The only thing that we can do with this data is classify this data in several categories. We cannot measure that. We are going to study initially only one characteristic. Then we are going to construct a table that has only one way. We have my variable, we have several levels, and we are going to count the frequency for each category. It's the only thing that we can do with this data, because these are no numbers, are labels, category, yes or no, political affiliation, religion affiliation, party affiliation, preference, whatever, yes or not. Then when we study only one characteristic, we are going to construct a one-way table. But if we are going to study simultaneously two characteristics, we are going to construct a two-way table, but we are going to study this later. Suppose an educational television station in a state that has not legalized marijuana has broadcast a series of programs on the psychological and physiological effects of smoking marijuana. Now that the series is finished, the station wants to see whether the citizens within the viewing area have changed their minds about how the possession of marijuana should be considered legally. Before the series was shown, it was determined that 7% of the citizens favor legalization, 18% favor decriminalization, 65% favor the existing law. An offender could be fined or imprisoned, and 10% had no opinion. A summary of the opinions after the video was shown of a random sample of 500 people in the area is given in the table below. The test as alpha level of significant type 1 error 0.01 to see whether these data indicate that the distribution of opinion differs significantly from the proportion that existed before the educational series was aired. That is a good study. That is the result after the study. 39 support legalization, 99 decriminalization, 336 existing law, and 26 have no opinion after this educational series. I will recommend do this problem using technology. You don't need to know how is this process, what is actually, you can understand. It's possible that you don't understand, but you can use technology, you can obtain the answers. First of all, let's send this data to StatCrunch. That is my data. We have the observed value 39, 99, 336, and 26. And this is the percentage or the proportion expected. That was the proportion before the study. And we are expecting the same proportion after the series was transmitted. Then my expected value will be 7% of the population support legalization. From this population in this area, we select a sample of 500. Then if this series doesn't affect this proportion, my expected value, when I select 500 people, I am expecting that 7% of them support legalization, 18% support decriminalization. The majority will support existing law, and a little 10% have no opinion. That is my expectation. How can we compute this expectation? We need to obtain 7% of 500, 35, 18% of 500, 90, 65% of 500, 326, and 10% of 500, 50. It's a good idea to do all of these operations in Excel. You can send this data automatically either to StatCrunch or to Excel. When you send this information to Excel, appear in this way. First of all, we need to obtain the sum of my sample, the sum of all people in my sample, will be this plus this plus this, actually is 500 people. We need to verify that this sum is also equal 100%, because it's possible that something is missing. Effectively is 100%. Then let's find my expected value. Suppose that this study was done perfectly. Then if I take a sample, I am expecting that this sample have exactly the same proportion of the population, exactly the same proportion, 7%, 80%, 65, and 10%. That is my expectation. Then if I take this sample, how much is 7% times 500? Is 35 people. 35 people from these 500 will support legalization. Let's copy this formula in all of these cells, but I need to fix 500. I need to fix 500 in this formula. Use dollar symbol to fix the row. It's not necessary to fix the column because it's not, in this case it's not necessary, but let's fix both. Then when I fix this cell in my formula, I copy this formula in all of these. And I got all expected value. The sum, if I copy this formula, here I will obtain also 500. The sum of all of these values will be 500. We have this information in StatCrunch. Then you have to go to Stat. In Stat, go to goodness of fit and chi-square. Goodness of fit. Can you see this test? Goodness of fit. I want to verify that this data actually fit this previous study. Chi-square, goodness of fit, then chi-square test. The observed value is located in this column, observed value. That was the observed value after the series. Where is located the expected value? The expected value was computed in this column. Then the expected value is expected value column. And that's it. Compute. That is the result. This is the observed value, the expected value, 500 people, the degree of freedom is 3. Why the degree of freedom is 3? Because we have 4 categories. We have 4 categories, 1, 2, 3, 4 categories. Because we have 4 numbers, my degree of freedom will be 4 minus 1. Then I would like to verify if this 4 count fits the previous result. For that reason, my degree of freedom will be the number of categories in my characteristic minus 1, always minus 1. Remember, in this case, the degree of freedom is related to the number of restriction that this number would have. Then the restriction is that the sum of all of these numbers should be equal 500. That is the restriction. For that reason, because we have 1 restriction, my degree of freedom, the degree of freedom of all of this value should be k minus 1. 4 different value minus 1. Minus 1 restriction. What is chi-square? This chi-square, how can we obtain this chi-square value? The formula for chi-square statistic will be given by this. This chi-square statistic measures how far away is my observation, my observed value from my expected value. How can we measure this difference? Very easy. Obtain the difference, observed value minus the expected value, because this observed value minus expected value could be positive or could be negative. Then if I want to sum all of this value, I need to square to transform all of these different positive. But I would like to obtain quality percentage of the difference respect to the expected value. If I sum all of this value for all measurement, this statistic will measure how far away is my observed value from my expected value. I can take all possible sample of 500 from this population. I compute chi-square for this sample, the chi-square for this other sample, the chi-square for this other sample. The distribution of all of these numbers will follow this distribution. This value always will be greater than 0, will be something like this. And the mean will be approximately the degree of freedom, in this case will be 3. Then I am expecting values close to 3 or smaller than 3 when I assume that this is really the true proportion in my population. If this is the true proportion in the population, when I take all possible samples, I am expecting that distribution. Then let's compute my test statistic for this specific sample. Let's go to Excel. Then first in this cell, we are going to obtain the difference between the observed value minus the expected value, but I will raise this difference to the second power to transform this difference in positive, and I am going to divide this by the expected value. Then let's copy this formula in all of these cells, and my test statistic will be the sum of all of these values. How can we obtain the sum? Very easy. I have the sum of all of these cells. I will copy this formula here. That is my test statistic. I told you, I was expecting, because if we have 3 degrees of freedom, 3 is here approximately, then I am expecting value close to 3 or smaller than 3. 13 is far away from my expectation. Then, because this value is far away from my expectation, then the population really doesn't have these proportions. It's different. Some of these proportions will be different. To verify this, we need a reference point. I need to compare this test statistic with a reference point to determine statistically that this value is far away from my expectation. That is the result in my stab lab. This is the result in SPSS. You can use any software. And this is the operation in Excel. That is not your work. You use this to show your work. You need to compute first the expected value with this formula, and you need to compute the test statistic with this formula and put everything there. Then the degree of freedom, because we have 4 different results, 4 different counts, or 1 for each category, then the degree of freedom should be k minus 1, 3. Then first of all, that is your work. That is your work. Define the proportion after the airing to be p sub 1, p sub 2, p sub 3, and p sub 4. Proportion for each of the citizens that favoring legalization, discrimination, existing law, and no opinion. The expected value is the proportion obtained in the previous study. Let's assume that this zero of program doesn't change the different opinion of people in this area respect to the possession of marijuana. That is my expected value. That is my null hypothesis. The null hypothesis always states that there is no change. The status quo is the same. The effect of this educational program doesn't affect the proportion of opinions. Then the alternative is at least one of these percentage is different. Then at least one of the proportions differ from its null hypothesis value. That is my test statistic. Remember, this statistic measures how far away is my observed value from my expectation. We need to compute first our expectation in this sample of 500. Then we compute all of this, and we can do this in Excel. And also, our reference value is obtained using alpha. With alpha, in this case, is 1%. That is the type 1 error. That is the significant level. What is the meaning of significant level? That we are going to use one value such that the probability to get this value or one value more extreme is 1%. That will be my reference point. Which one is this value? How can we find this value? First of all, I need to enter in this table through the degree of freedom, which is 3. And I need to find this significant level. 1%. Remember, we are going to use this notation for chi-square in the same way that we use the same notation for T and for C. Here we have this is the area on detail. Here also this represents the area on detail. Then this area should be 1%. 1%. Then which value is this in this formula? The value will be 11.3449. That is my reference value. This value is 11.3449. Then my rejection region will be defined according to alpha, which is 1%, level of significance, and the degree of freedom 3. Then we reject the null hypothesis if we obtain one value far away from my expectation. Then how much far away? If this value is bigger than 11.3449, this value. That is my rejection region. Then next step, after we do the null and alternative hypothesis, we need to verify that we can use chi-square distribution. We have two conditions to use chi-square. First of all my expected value, this no observed value, expected value, all of this expected value must be greater than 5. Doesn't matter if I have an observed value less than 5. That doesn't matter. but my expected value, all of them should be greater than 5. We guarantee that if we take a sample big enough. Then my sample should be big enough in a way that my expected value should be greater than 5. Then the other condition is my sample should be selected randomly. That is the two conditions that we needed to use chi-square procedure. Then my reaction rigor is this one. If I got a value bigger than 11.34, that is indication that my observed value falls far away from my expectation. We now calculate the test statistic. We did it already, but you need to show your work in this way. That is your work. You can use the result in Excel. That is the Excel result. You can copy all of this value, but you need to write the formula and you need to plot in the formula all of this number, and you can write the answers. Then you can conclude, because 13.24 is bigger than 11.34, my value falls far away from my expectation, then I reject that the population have no longer this proportion. Is different. At least one of them should be different. Since the value exceeds the table value 11.34, the data provides sufficient evidence at alpha 0.01 that the opinion of legalization of marijuana have changed since the jury was aired. That is our conclusion. It's very easy, and that is the best way for me that you can show your work using Excel. Also, if the problem doesn't give you this percentage and tell you that those percentages are equal, for example, in the previous exercise, talk about the 3 candidates, all of these candidates, we assume that all of these 3, there is no one that have more preference than other. Then my null hypothesis is the assumption that all of them have the same preference. Then in those cases, because it's not given this expected value for the percentage of the 3 categories, because in this case, my random variable in this problem could be, because we have a population, in this case, I will select a sample to verify we have only 3 categories, because we have 3 candidate categories, and we are going to count in this sample how many of them will prefer the candidate 1, candidate 2, and candidate 3. Then 3 values. Then the degree of freedom, because k is equal 3, the degree of freedom will be 2. Then how can we use a StatCrunch in those cases? We take 150 voters and we assume that there is no preference between these 3 candidates, and that is the observed value. The observed value were 61 the first candidate, 53 and 36. Let's verify with this evidence there is a big difference, significant difference between this percentage. How can we do that? Let's go again to StatCrunch. In StatCrunch we have 61, 53, and 36. 61, 53, and 36. 61, 53, and 36. Let's verify it. Actually, there is a significant difference between this value statistically. Then how can we do that? Let's go to Stat. Let's go again, goodness of fit and chi-square. Here, where is located my data? My data is located, you can change the name here in variable, but in this case will be variable 6, but you can change the name. And in this case, because we have no expected value, it's not given, we select all cells in equal proportions. That is my expectation, all cells in equal proportion. Then click compute and you will obtain the results. Chi-square and p-value, that is the p-value. Let's return to our problem to compute the p-value of my evidence. That is my evidence. What is the probability that we obtain this evidence of one value more extreme? We can use either StatCrunch or table. If we use a StatCrunch to obtain this p-value, we have to go to Stat, we have to go to goodness of fit, chi-square, my observed value is here, my expected value is here, and let's compute. My p-value will be 0.0041 because this is my evidence. This value, because it's smaller than alpha, alpha is 1%, alpha is 0.1. my p-value in this case is 0.0041. This value is smaller than alpha. Because this value is smaller than alpha, it means that my evidence falls far away, because it's the probability that we obtain this value, my evidence, or one value far away. When this value is smaller than alpha, then this evidence falls far away from my expectation. But how can we obtain this value using StatCrunch or using table? I will show you how can you obtain this using StatCrunch or table. In StatCrunch, you can go to Stat, calculator, select chi-square. In chi-square, we need to input the degree of freedom, that was 3, and the probability to obtain what, do you remember what was the, let's see, what exactly my test statistic? My test statistic is 13.249451, and compute. No, it's greater, because this is the probability that is smaller than this value, but I want greater than this value. It's exactly 0.00412706. That is my p-value, probability to get one value, one sample with this value, or one value more extreme. Also, you can use the table. In the table for chi-square in 3 degrees of freedom, you can observe that 13 is located here according to this sequence, because it's increasing all of this number. Then because 13 is here, and then the corresponding tail will be smaller than 0.01, because can you see all of these tail will be every time smaller. 13 should be in one column far away. Then the corresponding value here is smaller than alpha. It's another way to obtain the p-value. Okay, let's stop here.